The paradox of the Methuselah star. For countless generations, humanity has lifted its gaze to the silent dome of the night sky. Beneath that endless canopy of darkness, we have been struck by the glittering constellations above. These points of light have inspired sacred myths, guided lost travelers, and driven philosophers and scientists alike to ask timeless questions. Where did it all come from? How old is the universe? And what role do we play within it? In the modern age, science attempted to provide an answer. The Big Bang Theory, introduced in the 20th century, painted a bold picture of creation. It suggested that everything, space, time, energy, and matter, was born in a single instant of unimaginable intensity. According to this model, the universe erupted into existence nearly 13.8 billion years ago. From that singular moment, the cosmos began expanding outward like ripples across an infinite sea. Galaxies took shape, swirling with billions of suns. Stars ignited and burned, seeding the universe with light and heavy elements. Planets formed from stardust, their orbits sculpted by gravity. And eventually, on one small, fragile world, life itself emerged. This became the grand narrative of existence, a cosmic story embraced by generations of scientists. Yet even the most celebrated models are never beyond question. As telescopes grew sharper, the universe began whispering secrets that seemed to contradict the Big Bang's tidy timeline. In 2023, NASA's James Webb Space Telescope, JWST, detected ancient light from objects so old, they appeared to predate the universe itself. If true, this meant that some stars might be older than the cosmos, a paradox that shakes the foundation of modern cosmology. At the heart of this mystery lies one star. A faint but legendary object that astronomers have studied for decades. Its catalog name is HD 140283, but it is better known by its haunting nickname, the Methuselah star. Methuselah rests about 200 light-years away in the constellation Lyra. To the naked eye, it appears unremarkable. But hidden within its faint glow is a puzzle that has left scientists baffled for nearly a century. Astronomers discovered that this star is unlike the others. It races across space at a blistering 4,483 kilometers per second. Its breakneck speed hints at a violent past, perhaps torn from a smaller galaxy that collided with the Milky Way nearly a billion years ago. Yet speed is not what makes Methuselah famous. Its true enigma lies in its age. Early measurements suggested Methuselah could be as old as 16 billion years. That staggering figure would make it billions of years older than the universe itself. Later refinements reduced the estimate to about 14.46 billion years, with an uncertainty of 800 million. But even then, the numbers still do not align. This uncomfortable discovery forced scientists to face a dilemma. Either our cosmic clock is flawed, or the universe is older than we dare to believe. Measuring the ages of stars is a difficult art. Unlike humans, stars carry no birth certificates. Astronomers must instead search for subtle clues hidden in starlight. They analyze brightness, color, and chemical composition. They measure the rate of spin, and how a star gradually slows its rotation over time. This method, known as gyrochronology, is like watching a spinning wheel gradually lose momentum. By comparing these traits with models of stellar evolution, scientists can estimate a star's lifespan. And yet, Methuselah refuses to fit neatly into any model. Its chemical makeup suggests it was forged in the universe's earliest years. Its low metallicity reveals that it lacks the heavy elements younger stars inherit from multiple generations of stellar death. Its unusual motion tells us it has survived collisions that destroyed entire systems. Its faint glow and slow spin whisper of an antiquity beyond imagination. No matter how astronomers study it, Methuselah seems to carry an age that predates the universe itself. To grasp this mind-bending problem, imagine condensing all of cosmic history into a single year-long calendar. At midnight on January 1st, the Big Bang erupts. In the early months, galaxies form and stars ignite. By late summer, planets and solar systems take shape. On December 31st, just seconds before midnight, Earth appears. And human history? It occupies only the final heartbeat before the clock strikes 12. Now, place Methuselah on this calendar. If the universe is 13.8 billion years old, Methuselah insists it was already shining by November, before December had even begun. Clearly, something does not add up. Either the cosmic calendar is miscalibrated, or Methuselah is the greatest trickster in the cosmos. The paradox stands unresolved. And it challenges not only our science, but also our philosophy. Rethinking time, dark matter, and the future of exploration. The mystery of Methuselah forces us to confront unsettling questions. Could the universe itself be far older than we think? Or are we misinterpreting the clues written in the light of stars? A groundbreaking study from the University of Ottawa offered a daring possibility. Physicist Professor Rajendra Gupta suggested that the universe might not be 13.8 billion years old. Instead, it could be nearly 26.7 billion years old, almost twice as ancient. How could this be? The current estimate of cosmic age depends heavily on redshift, the stretching of light as galaxies recede in an expanding universe. But what if redshift is not caused only by expansion? Gupta revived an idea first proposed by astronomer Fritz Zwicky in 1929, called the tired light hypothesis. This theory suggested that light could gradually lose energy as it travels across vast distances. If combined with modern physics, Gupta argued, redshift might be the product of multiple processes. If true, this could explain the paradox of Methuselah. It could mean the universe is vastly older than we ever imagined. History reminds us how fragile our estimates are. In the 1920s, Edwin Hubble believed the universe was just 2 billion years old. Later refinements doubled, then tripled that figure. Eventually, it stabilized at today's accepted 13.8 billion. But what if that number is still too small? What if the universe has endured for nearly 27 billion years, harboring entire cosmic epochs that remain hidden from our view? Even as this debate unfolds, new mysteries closer to home demand attention. The European Space Agency's Gaia spacecraft, which mapped nearly 2 billion stars with extraordinary precision, uncovered an anomaly. Stars on the outer edges of the Milky Way moved more slowly than expected. This surprising result offers two explanations. Either our galaxy contains far less dark matter than we thought, or our very understanding of dark matter, the invisible substance thought to make up most of the universe, is fundamentally flawed. Dark matter was once imagined as the cosmic glue binding galaxies together. Without it, stars should drift apart. But Gaia's data slashed the Milky Way's estimated mass to just 200 trillion solar masses, 5 times less than earlier predictions. This suggests not only less dark matter, but also less visible matter. Could it be that our models of gravity are incomplete? Could entirely new forces be shaping the universe in ways we cannot yet comprehend? At the heart of this unfolding mystery is NASA's James Webb Space Telescope, humanity's most powerful eye on the cosmos. With its ability to peer deeper into space and further back in time than any instrument before, Webb is already reshaping our understanding of creation. It has uncovered galaxies far earlier than theory predicted. It has observed newborn stars and distant planets in exquisite detail. Some of these exoplanets lie in the fabled habitable zone, raising the possibility of life beyond Earth. Even the discovery of the smallest microbial organism out there would change everything. It would redefine biology, evolution, and humanity's place in the cosmic story. Each revelation from Webb leads to bigger questions. Do the laws of physics remain constant across all of time and space? Or do they themselves evolve? Is the universe not only older, but also stranger than we ever dared to imagine? Could hidden cosmic forces, unknown and unseen, still be waiting for us to uncover them? We stand now at the threshold of a new era of exploration. The paradox of Methuselah, the riddle of dark matter, and the hunt for alien life all point toward one truth. The universe is far more mysterious than our textbooks admit. As the cosmos continues to expand, so too does our knowledge. But with each new answer, even deeper questions emerge. The path ahead demands bold curiosity, sharper tools, and above all, the courage to challenge assumptions we once thought unshakable. Perhaps the greatest revelations of all still await us. Not in the answers we hold today, but in the